discrepancies in some of your values are concerned. The book is doing something a little bit differently. The book is finding the average value to be n times p. Okay. This means average, mean, x bar. I used it over here yesterday when we were doing standard deviation. So in this case here, they're taking 192 and they're multiplying it by 0.25. So half of 192 would be 81, half of that would be 40.5. So they're saying that the average is 40.5. You okay with that? What they're doing then to get the standard deviation is they're taking the square root of NP times 1 minus P.
Is this 192 times 0.2548?
Yeah, it's not 81.
Oh, I thought it was 182, sorry. So 48. So they're doing that, they're taking, whatever. Now they're taking the square root of that. So it'll be square root of 36. So they're giving you an average of about 48 and a standard deviation of about 6. When they calculate that through using the formula that they gave you in the book to do that, I didn't have you guys do that, so don't worry. That's where they're coming up with their values. They're doing, remember how I told you yesterday, a lot of times in statistics, they do certain things to numbers to norm the data? This is one way of norming data, okay? This is one way of setting it up to become norm by using the percentages to work with it. There's rounding error, there's that. I had you guys just using your straight calculator CDF function. It's clean, it's quicker, it's, for what we're doing, it's fine. It's fine, it's fine, it's fine.
Everything's fine.
What's that? Oh, darn it, means I have to let you use a calculator. So, no, but that's why they come up with their values, because then when you can get, because see how fast it was to get an average and a standard deviation?
Yes.
You could quickly mark out your lines and get your percentages. That's the point of being able to do a fast calculation with a standard deviation. For us, what we're looking at is we have an n value of 192, a p-value of 0.25, and we're looking at is what's the probability that 42 or more, we're looking for that k to be greater than or equal to 42. So now when I do my CDF, I'm going to do 1 minus the bino CDF of what?
192.25.
Correct. Okay, and that's why yesterday we were talking about putting things on the number line, because if you look at the number line, it's telling you where your breakpoints are going to be at. That's kind of what it looks like. When you're talking about between 36 and 60, is it including 36 and 60?
Yes. Between 36.
I don't remember.
I'd say so.
People were asking about this. I'll make sure it says more than, or it'll say including 36 and 60. I'll make sure it says something like that. Or, you know how it says at least? We know that at least means it includes. At most, it includes. If it's more than, does it include?
No.
Less than, does it include? No. But if I put it something where it's going to be within parameter, I'll make sure it says includes. Does that make, just for clarity, can we talk about that third hour, about the semantics of the wording? I'll make sure it's clear. Yes, ma'am.
Okay, so if it's like at least, that means it's like less than or equal. Like K is less than or equal to.
No.
I mean, K more.
At least
The
means
number
it's,
is less than or equal to, right?
no. Remember, the least means it's the smallest value that K is going to be. So K is always going to be greater than or equal to that value.
Okay.
K is always greater than or equal to whatever for an at least. It's opposite of what you want it to be, what it sounds like. And it's at most, that means it's the biggest value it's going to be. So the largest value you're going to get up to is 30. At least and at most. Just, you guys, the way I'm breaking out the test, it looks like it might be like 10, 11 questions tops. And they're not difficult. I'm not trying to make it horrible, scary bad. people have been asking, you see some statistic things on ACTs and stuff like that. Normally, it's just your straight independent, dependent things with a deck of cards. Or some very simple counting principle. You know, how many times 10 people can be a president, vice president, that kind of thing. It's not this in-depth binomial distribution type thing. You don't see this very, very often because it's material that normally isn't covered in the two courses. Yes, sir.
So this test tomorrow is going to include like this.
Oh, I'll go over, I mean, let me finish these couple things here and I'll show you.
Is it going to be like an even distribution of like?
Yeah, it should be straight across the board. It should be straight across the board. I'm not trying to trip anybody up on anything here. Okay? Yes, ma'am.
So is this like
Yep. Actually, I was talking with Miss Denny about this stuff yesterday, and they haven't even gotten to the binomial distribution stuff this year. They were doing other, they didn't get to it. It's one of the last things they did. Just ran out of time. And like I said, this is the first year that I've been able I think this is the sixth year that I've taught Algebra 2. This might be the first year that I've gotten this in depth into it.
So
I'm rare. You're something.
we are pros.
Well, we also skipped 4 chapters to get the book. You know, if not just, I'm not saying, I'm just saying. But yeah, remember the trick here is when you're 36 to 60, you find the 60 value, you back up the 36 value. That was your inside stuff. Okay. Other than that, other questions from the homework from last night? Which one? What's that? All right, so you have randomly chosen students who took the ACT or the SAT, scored at least a 736 in math and at least a 727 on English. The scores are independent. So what you're going to do is you're going to find the probability of the math, multiply it to whatever the probability of the English was. So you're going to have to draw out 2 separate graphs.
You can just
Oh, I think we got it.
that's math and English.
Thank you. Thank you.
Just that question.
I know, I'm just being. What? So here's the English.
Grandma has the shirt he wearing. He wore it last night.
So that's English. Oh, I wrote the same one down twice. Darn it. Okay.
I think you switched English and math.
Yeah.
It's alright.
Math is hard.
It's okay.
Oh.
You did, because you got English there and math there.
No, I had the titles above it. So math. No, your turn. Keep it going. Yet. The case yet.
I was just going to go with your Obama jokes, but I think that's probably not appropriate. Anyway, so let's see. The 736 at least, so this would be the low end on 736. So they want everything going that way. Okay? So this would be from here to here is 50%. Here's another 34. Here's another 13.5. So what's left over will be 1 minus all that jump. On the other one, you have at least a 727, and it's going to be the exact same percentage because it's the If you want to above the second standard deviation, so you'll just take whatever this number is, multiply by itself.
What is that number? Wait.
0.025
Yeah, I got it.
times 0.025 is 0.000625.
Yes.
Yes, because this would be 0.025 squared, it should be
What's easier to split up?
yeah, because what you're looking at here is, oh, here's because what happens is, you know that on half of the graph, when you have half the graph, hold on guys, we know that's 50%. Then we came into here, and here, and you want everything over here. This was 34, this is 135.
Yeah.
So all you have to do is just add those three together and subtract it from 1. And that gives you everything that's left.
I didn't even do it.
You know what you probably did? You might have just added these two together and forgot about this one. That's it. They need to multiply together. What else? Anything?
No, that was easy.
Alright.
Be good.
Couple things that came up from earlier today as far as when do you use which one? What is it?
Well, you use the binom CDF when you need to add them together. And you use the PDF one when you just need to see some value.
And like store it.
Do you remember how, can you show us how to put it into your list? Because I don't know how to do that.
Second instance, store second.
And she's right. When you're using the CDF function, is when you're adding them all, when you're trying to add up a bunch of them. It's when you see it's like, you know, k is less than some number, or k is greater than or equal to some number. That's when you're using your binomial CDF. The binomial PDF is when you're looking for a specific value, when k equals 2. Or, remember the puppy problem on the worksheet when they were looking at what is the expected value? That's one way that you can send it to a list, okay? So if you think about the PDF file is for a single value or a list. And that's really the only time that I can think of it, the PDF being really useful. Where was it? The puppy problem. In the puppy problem, they're talking about golden retrievers. A registered golden retriever gives birth to a litter of 11 puppies. Assume the probability of puppy being male is 50%. It says then, because the dog owner can expect to get more money for a male puppy, what is the most likely number of males in the litter? So what you're looking at here is that you can create a list rather quickly in the calculator. If you go to your stat edit L1, oops, I don't have all that in here. Anyway, I'll just overwrite it. What we would have is we have 11 puppies. So we start at 0 male, we go all the way down to 11. So you'll put in 12 entries. 0, 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. You can, this takes forever, this calculator. I hate this calculator.
Just use a regular calculator and close it again.
This. So now if I go to my quit and I do a bino, so bars,
Second bars, alpha, apps. That's how you get to it quicker.
Second bars alpha B.
Do second bars alpha apps.
Where's the
It's the
app?
purple one, right there. No.
Second.
It's second.
Oh, there it is.
Alpha apps, yeah. For CDS. And then for PDF, it's alpha.
Today's Wednesday.
Okay.
Let's Bino C. I want Bino PDF.
I was trying to tell you.
Well, you know what?
Second bars, I think it's
Catalog.
alpha map.
Alpha math.
All right, so we had 11 trials because 11 puppies.
Like alpha A.
Our p-value was what? 5? I don't have an x value, so I'm just going to go right into here. And what it does is it's going to do our binomial PDF, which means it'll calculate all 12 of those values between 0 to 11. And you're going to get that. Now, don't press anything on your calculator. There's one of two things you can do. You can start pushing to the right now, and you can just scroll through them. Or now you would hit your stove, second, L2.
You are not almost.
Okay? Because now then you hit enter, it will send all of those values to your stat, edit, L1, L2. And then you can scroll through to see which one of those values gives you the highest percentage.
So, if I remember, like, 2 of them were the same, I think.
Yeah, and that's okay, and that's fine, and that happens. And the reason that's happening is because it's 50%.
And it's an odd number.
And it's an odd number.
So should we just write like 5 and 6?
Between 5 and 6, 5 or 6.
5.5 puppies.
You get 5.5 puppies.
You have 5 boys, 5 girls, and a hermaphrodite.
Yep.
Congratulations.
Merry Christmas. Please.
It wasn't even good.
It was so good.
It was new and
All right, thank you. Question. Quiet, please. For the PDF?
I don't know what you just did.
All you have to do to get to the Bino PDF is second, bars, and then just scroll through and look for Bino PDF. Well, where's your calculator? Once we do this, when you get to your Bino PDF and it comes up, you put in the Bino PDF 11, comma, 0.5, close the parentheses. All right? You type in the 11, comma, 0.5, close parentheses, hit enter. It's going to come up with a whole bunch of stuff. You don't care about all that stuff. What you're going to do is press stove, second from the bottom on the left, and then you hit second, L2, and then go back to your list and look for it. And that's really all it is. Sir?
A couple of questions. First of all, what is March short for?
Varsity.
Blue?
Alright, and also, well, I know you already said you were going to go over, but are we go, on this far as we can go all the way back to like license plates and like?
Oh yeah, I'm going to show you, I'm going to talk about it real quick here.
Awesome.
Okay. But yeah, that would be the time that I use the PDF, but other than that, I mean, I can't think of any other time that we use PDF, really.
Yeah, can we go
When
over
you make
the
it a
math
math
like
book,
Yeah, I was just going to talk real quick about a couple of things we had on here. When you start going back to the old stuff, 12, 1, 2, 3, and 4, that's where we just did some simple probability and you're counting the permutations and combinations. When you're dealing with permutations, do order matter?
Yes.
When you deal with combinations, do order matters? No. So ordered matter.
No combo.
Ordered matters is when you're dealing with, like, you have 10 people. How many ways can 10 people be picked, or 4 people out of 10 be picked to be president, vice president, secretary, treasurer, something like that? Okay. Yeah, because that's all you're looking at.
That's
That's a permutation.
Yeah, because the order matters.
We
Okay?
go over
When you're like multiplying
So
combination
permutations are
times,
bigger, like we did,
like 4 choose 1 times 13 choose 1. Can we go over
I
that?
was going to be more than happy. I'm going to go look at the actual
No,
quiz
that's
question
the
like
only thing I
that.
don't get.
Do you still have your quiz from earlier? Yes, sir.
so permutations since order matters, like if it was 10P5, that would be greater than 10C5.
No, because the combination is how many ways can you arrange it? How many ways can you pick 5 things out of 10? You can pick, the order in which they're placed doesn't matter, but if the order matters, shouldn't it be more restricted?
If the order matters, shouldn't there be more ways to do it? Without
Now,
having like
because you
maybe
can
like.
say all flip the way these people underneath those offices, but there's like 16 ways that they can be placed.
It doesn't matter.
I'm looking at number 5. It says from a standard 52 card deck, that's what all normal decks of cards are, except for peanut obviously.
Yeah.
What is how many ways can you have exactly 3 of one kind
And 2 of another.
and 2 of another? Remember, 3 of a kind means a pair plus 1. That's what 3 of a kind means. So it means having 3 kings, 3 sevens, 3 aces. It's basically what we call a full house. In poker, 3 of a kind and 2 of a kind is called a full house because you get 5 cards. Now, if I'm looking at 3 of a kind and 2 of another, the first thing you have to identify is what kind you're going to get, what card you're going to get.
We're gonna get.
I'm sorry, this isn't number 5. This is number
10.
This is number 10. Yeah. Sorry, number 5 was the other way. It was the spades and hearts or whatever it was.
Now, can we do that one too? 'Cause
We will. They're subtle. So first thing you have to do is pick a card.
5.
Okay. So we're picking a 5.
Oh.
So we have. There are how many cards? There's 13 cards. And we're taking out, so you're just picking one card. So you have to get 13 cards and choose one. Now, once you get that one card, I got a 4, you got a 5. How many of those 4s do I need to get? 3 of them. So how many 4s are in a deck of cards?
4.
So this is a 4, choose 3. So that gets me my 3 of a kind. Okay? So I now have my 3 of a kind. I'm looking at how many different ways can this be done. It can be done with 4s, it can be done with 6s, it can be done with 9s, whatever, it doesn't matter. All right? Now, I have to get 2 of another kind. So basically, I'm going to get a pair now. So I've already picked one card. I have to get a different card. So there's 12, choose 1. And of those 4 cards, how many do I want? 2. And that's it. That's all that is.
Yeah,
I don't have to worry about with replacement, without replacement or anything here, because I'm not dealing with probabilities. I'm just looking at counting the number of possible card hands that there are. Okay, that's all I'm looking at. That's all that is. Yes, sir?
So if there's something in our problem and it's like, has to do with 2 different kinds, there has to be 2 different kinds to draw, it's gonna have to do with 13 choose 4 and 12 choose 1.
Yeah,
Just
sure.
remind me what
Well,
color.
actually, you're looking at, when you have 2 kinds, like you want to get 2 pair, you have to do a 13 choose 2. That was that one weirdo problem where you were looking at how many different ways can you get 2 pair, 2 different pair. Because if you select just the 13 choose 1 and then a 12 choose 1, since you only picked 2 of one card, the other 2 are still floating in there. It's the weird oddball one that I did not worry about, if you recall.
Yeah, I know, I'm saying it's something like that.
And I just reiterated that I did not worry about.
I know why.
It's not worrying about.
Okay? So that's how you get that. This isn't probability, guys. This is just how many different ways can it be arranged? How many things are out there that make that work? Okay? Now, if you go back to the other one, yes, ma'am.
Oh, I was gonna say, could we do like a permutation example too?
No.
We just did one.
Oh, yeah, but I need.
Discussing.
Okay.
Be easier if you found one.
I,
So you want 3 spades
you're not right, so.
and 2 hearts.
3 spades and 2 hearts.
So the specific thing here is that you're trying to get 3 of a specific suit and 2 of another suit. So how many suits are in a deck of cards?
4.
So you want 4, choose 1. Of that suit you pick, how many cards are there?
13.
How many do you want?
13, choose 3.
And then how many suits are left? Choose how many?
Choose 1.
And then how many of that suit do you want?
13, choose 2.
So this is still a combination.
You're just looking at you're
Yeah.
counting
I was
possibilities.
just wondering because I thought you said permutation.
I mean,
Oh, I never said permutation. Somebody sits in front of you did.
Mr. Murphy, when did you get hit in the head?
Saturday.
I was making sure you remembered something.
Oh, I recognize it very often.
Whatever time it's closed on.
Okay.
Now she doesn't anything. Apparently, Allie is trying to tell people that she hit you.
Who?
Wait, me? Well, that was at lunch. That was at lunch. I forget, what did I say exactly?
I hit Mr.
Probably you tried to rough him up.
No, I said, no, what did I say? I was like, my shoulder hurts. And I was like,
Oh no, Allie, you want your flex pass.
oh, my flex passes, yeah, on the black market, because I had 2 flex passes. And I decided, no, and I said it ran a black market for flex passes.
Oh, what?
And then Julia said that you got beat up when you went to the black market to try and get your flex passes.
You failed before about like. I wasn't there.
No.
Allie, can I grab my ball phone?
No.
No.
No, it's a weapon.
I just want to say
Shoot it
clear.
with the bullet arrow. Or hit the basketball hoop dunk.
I think he wants his flex passes back.
I don't have any of them.
Allie, you have 2.
I have 2. Wait, I have 2 that are not for you. One's for you. One's for you. And I don't have any. I have one's for you. One's for you.
I don't have it.
Yours are. Yours are both not for you.
Oh, but they all have bullets on this side.
Can we do something for money for you today? So I have a reason for it.
Once again, you have an example. So yeah, other than that, when you get into this, that was basically what we're looking at. Don't forget when you're dealing with binomial expansion, the one problem that most of you guys got wrong on here was the idea of a thing called a coefficient. A coefficient is just the number, whereas the term would be all of it put together. Also, got number 9. When you do this,
Oh, yeah, we're gonna have to do that.
what do you do to the 2?
Distribute the 5.
A lot of you guys forgot how to do that.
I tried
so.
to.
Also, -1 to the 4th power is what?
1. It's 1. It is 1.
Yeah, in this case here, most people forgot to multiply it
Because it's
to
9
raise
1
the
times
2.
9 to 1 is 1. Yeah.
Trying to think if there's anything else here.
Is there gonna be geometric probability?
There could be, but that's easy.
Yeah.
Shaded over total. Let's see. I was going through some stuff in here, and I was just kind of looking at the chapter review in the book,
Probably a good idea.
and it's got a little bit of everything that we've done. A lot of it is probably easier than the stuff that we did. Not that it was stuff we were doing was all that difficult, but you'll notice there's some stuff on here like find the number of permutations. 6p6.
Oh, yeah.
So you're telling me you just want me to press the button on my calculator? Okay. So that looks boring. But if I'm looking at how many different ways can a 5-digit zip code be put in order if the digits 0 to 9 can be used? Well, does order matter in a zip code?
Yes.
Why?
Yeah.
Because if you put the numbers in the wrong order, then it's a different zip code.
Yeah, pretty much. 'Cause
Correct.
1, 2, 3, 4, 5 is different from 5, 4, 3, 2, 1.
Because you want to get your mail not your grandma's.
My mom, my grandma gets my
6015 or 51106.
Well, all right, never mind then.
We live in 123.
So that's an idea that you have to be able to use your zip code. So there are 10 digits, you're choosing 5. So it's a 10, you're a 10 permute 5 is the order match. Combinations, like we were saying, the combinations when you're looking at a lot of the card stuff, when we're doing that, you're just looking at how many hands can be made. We're not doing a probability out of that. We did do some of the probability, but then you have to remember that there's almost 2.6 million 5-card hands that you have to divide out. I mean, you can easily, don't have to memorize that because it's just 52 C5. I mean, the combinations are. Yes, ma'am. I don't know. I'm sure there's some rationale to it.
A lot of the ones that I hear are 6011.
They definitely also have a 60.
Freaking dinero.
Hannah, they have it for like 2%.
Why don't you Google how to decode a zip code?
Oh, you're talking about at lunch? It's done at lunch today.
We got into this one here. You must write a report on 3 of the 12 most recent presidents of the United States. The order in which how many different ones, or how many traditions. You need to write reports on 3 of the 12 most recent presidents for history. The number of possible combinations of writing these reports would be, the order doesn't matter when you're just picking them out of, 3 out of the 12, so it's a 12C3. You have a calculator, you don't have to worry about how to set it up. You can do that if you want, but I don't care. You got your binomial expansion, the idea of whether or not having to write it all out, or find me a specific term, which is what we've done. Probability, it's 6-sided, or tossing dice, it's flipping a card, it's not scary. The idea when you're talking about the probability, then you get into the compound probability. Are they independent or are they dependent events? Do you know how to calculate them through? Remember, independent draws, you're multiplying things together. What's the probability of picking, rolling a 2 and then rolling a 2 on a single-sided die? 1/6 times 1/6. The rolls themselves do not depend, each roll is independent, there is no dependence there. The dependence came into when you're talking about picking more than one card. If you're going to pick 3 cards, what is the probability that the first card is a king, the second one is a jack, the third one is a 2? If they're being replaced, if they're not being replaced. That whole thing. So if they're being replaced, do you have to worry about your changes in denominator? If they are not being replaced, you have to worry about the denominator as well as sometimes the numerator if it's asking you to pick more of the same card. Okay. So that's where those things go. Independent, dependent also worked along the lines of what's the probability of flipping a card and getting a 5 or a 6.
Oh, it's 8 out of 52.
It'd be 8 out of 52.
You say flipping a card?
If flipping a card, it's going to be a 5 or a 6, it'd be 8 out of 2. What about the probability of 5 and a 6?
I don't want to.
0.
0.
What? I can't think. Get up one.
Well, what if it's written on it?
Extra credit rate.
I like you too.
Like, I can't see her face, but I can tell she's like, I don't care.
But then you also have the idea of what is the probability of getting a 5 and a heart. It is a thing. How many of that thing is there? Very good. Yes, ma'am.
Where did you do it from?
No, I'm really busy right now.
57.
Oh my god.
I was so good
at doing that. She just disregards whatever you just said to her.
Probably. I don't know.
Oh, you have a result for our zip code decoder. Please, everybody listen about why zip codes matter.
The first number in the code represents the general geographic area of the nation, 0 in the east moving to 9 in the west. The next 2 numbers represent regional areas, and the final 2 identify specific post offices. The lowest zip code is 00501. A unique zip for the Internal Revenue Service in Boltsville, New York. The highest zip code is 99950. It is in Arkansas.
Wait, it's not shoes.
That's not very far west. You mean it's not AK? Is it AK?
Alaska.
I'm not good at the states.
Is it wide for the West Coast? Why is like way in the?
I thought it was a choose your zip code.
No.
Why did
You can choose how you should share to town. You
No, you
go to
didn't.
the wall.
It's 601.
Nah, I'm taking
Isn't it?
I
Are
want.
you thinking about area codes?
I was thinking about garage codes. I was like, since when did they choose your zip code for you?
Seriously? Are you kidding
What does
me?
that have to do with post offices?
All right, so everybody must figure out Hannah's garage codes. I'm guessing it's like, oh, you got to pick it. Ours is 60115.
Wow, you have a garage?
It's
What's the chance?
Mine's just really near and dear to my heart.
Your zip code or your garage code? Near and dear to your heart. So let's see. How many digits is it? 4 or 5?
Is it 4?
No, give me 4. Is it something 4 or 5?
One number.
4 digits. So we have a 4-digit code that matters to
It's a
Hannah's thing. So there's a 4-digit code.
It's 4444.
All right.
Oh, you know how the numbers, they have like 3 letters assigned to them? Maybe it's like a dog's name or something.
Possible. Now, it's a 4-digit, and it has, I'm assuming it has, it's a regular touchpad, so there's 10 digits, correct? Bless you.
Correct.
All right. So it's 4-digit, 10-digit, it's a 10,
Numbers.
10 numbers. And we need to, does the order matter in which
Yes.
that goes into? So it's
Yes.
a permutation or a combination. So it's a 10P4. So now, what we're looking at is how many different possibles are there? It could be a lot.
5,040.
So there's 5,040 possible codes. Now, what we can do here is ask a couple of questions. Are there any repeaters?
Yeah.
Okay, so now you know that something's been repeated. So does that cut? It still doesn't help us. No, actually, it still gives us the same number of value here.
Is it a year?
Well, I'm sure
It's not a year. Near and dear to your heart.
Wait, did you?
And it's not a year. So
Wait a
that's
second.
Wait, is it near your?
What's Abby's birthday? I know it.
Don't say it!
If I knew Abby's birthday, I would know it, because it's 7/7. No, it's probably in order, so it's probably Abby's birthday 7/7. Because she was born on the 7th and Kate was born on the 7th, so Abby was probably born on like the 20th.
Oh, yeah, makes sense. So there's your duplicate. So, but it's gonna go. It'll probably go in oldest to youngest.
Yeah, and Abby's
so
the oldest.
It'll probably be, so Abby's the oldest. So let's see. 2 digits. Now we have 2 digits to worry about.
I know it's an
So now what we have is to worry about a 7/7. Now we have to get these 2 numbers here to get out of it.
I don't want you guys to know my garage.
But you see how this works?
Yeah, it's cool.
That's
You're welcome that I know their birthdays.
So
But now think about all you have to worry about is 2 digits.
Yeah.
So
You have a 10.
You can try it.
I mean, you can sit there and go through these 2 digits, knowing that they have.
Or just check the signature.
It is.
That's 10.
So you have to do a 10.
How do you know that the last 2 numbers are 7?
Well, we don't know
You
that
didn't say they weren't.
we know that there's 7/7.
Do you want to use Mastermind to show me?
Wait, yeah, what's it? No.
You thought about it because it's gambling to you. All right, back to the rest of this.
Oh man,
Um,
just leave it with that cliffhanger.
That's worth. We don't want to. I don't want to take
Breaking
responsibility for her lawnmower going missing
Okay.
28.
again.
You get the near to my heart, my sisters.
You're such a full of baloney. Are your eyes brown? You ever heard that joke?
I have a brown, by the way.
Full of crap.
Oh,
Claire's full of crap. She has brown
Probability random draw, given the marbles. Remember, when you're doing replacement without replacement, it's not that bad. Now we got down to when we did the binomial experiments. When you're dealing with the binomial experiment, that was the idea where they gave you a percentage and they wanted you to get X number of successes, the exact value, okay? This was one way of doing it, was just to use the formula straight through. I think we did a problem with that. It was these guys here, the binomial probabilities. When you had 4 possible test questions, you had 4 choices of test question, what's the possibility of guessing it correctly 15 times out of 30?
Oh, this is the one.
Yeah, this was that 30, choose 15.
And then,
Your p-value, 0.25. Very good. This wasn't difficult, but it was, and then you had the other one be the 1 minus that.
So, 30 minus 50.
Yeah, very straightforward. It worked real clean. Trying to think if there's anything else. Just know when to press the right buttons and you'll be okay.
No way to press the right, but Allie, don't do that.
That's bad. Unless you need to.
Wait, other.
Oh, Allie, you had a question. I avoided you really badly. I'm sorry. What's your question, Allie?
I figured it out. 57 on page 7 of 6.
What unit is it? What section?
12.1.
Okay. I'm sorry, Allie. I think we made fun of her too much because she got really quiet.
Wait, I got it.
She thinks she's the reason he has a black eye.
Hey, computer program. Many programs require a user to use a password. Shortest allowable passwords are typically 6 characters and can contain both numbers and letters. How many 6-character passwords are possible if characters can't be repeated and characters cannot be repeated?
So when you do 26 to the 6th power.
Careful. You're talking about numbers and letters. How many letters are there?
10. Wait,
36.
26, and how many numbers are there? 10 plus 26 is how much? 36 possibles to start with.
Oh.
Okay.
To the 6.
Wait, so it's just 26 to the 6th?
If you can repeat it,
And then it's
yes.
36, 35.
And then it'd be 1 less each time if you can't. Does that make
All the
sense?
way to 31.
31. So.
There's 22 possible numbers.
Oh, yeah.
Faster. And what's a lot of times with those, let's just